Coming to this problem, find out weight density and specific gravity of 1 liter of liquid which weighs 7 newtons. So in this problem he has given volume. Please understand that I have already explained relations between volume and meter cube and liters. So 1 meter cube equal to 1000 liters. Okay, 1000 liters. So from this we can understand if you want 1 liter, 1 liter equal to, you can take this one, 1 divided by 1000 meter cube. Okay, I have already explained. Okay, coming to this one, we can first we can find out weight density. Okay, weight density of liquid equal to density of liquid equal to weight of liquid divided by volume of liquid. Okay, so here you see here we are converting the 1 liter converted into the meter cube. 1 from this relation we can convert to 1 by 1000 meter cube. So therefore here weight of the liquid equal to 7 newtons. So that 7 newtons divided by 1 by 1000 meter cube. If you simplify this one, the 1000 get into the numerator. 7 newtons into 1000 divided by 1 meter cube. This is equal to 7000 Newton per meter cube. This is the weight density. Next we can find out mass density or density. Density of liquid equal to mass density of liquid equal to, we can go for different ways, but we can write in simple way, weight density of liquid divided by acceleration due to gravity. We know that in previous videos weight density equal to density of liquid into acceleration due to gravity. From that relation I developed this relation. So weight density of liquid equal to mass density of liquid into acceleration due to gravity. From that I want to density of liquid, obviously that is equal to weight density of liquid divided by g. This is equal to weight density, already we found out that is 7000 newtons divided by acceleration due to gravity 9.8 meter per second meter cube. Weight density equal to Newton per meter cube, g equal to 9.8 meter per second square. This is equal to 713.5 kg per meter cube. That you have to understand. How to convert these Newton per meter cube and meter per second square, kg per meter cube, that you have to understand here. Newton convert into the kg meter per second square. I would like to convert this, because density of liquid that should be in the kg per meter cube, so that we know that 1 Newton equal to 1 kg meter per second square divided by meter cube divided by meter per second square. So that if you simplify this one, kg meter per second square divided by meter cube into meter per second square, they get cancelled. So finally you can get kg per meter cube, kg per meter cube. So such that we can arrive this weight of density of liquid equal to 713.5 kg per meter cube. Okay, next specific gravity of liquid equal to of liquid equal to what we can write here, weight density of liquid divided by weight density of water, or density of water or density of liquid divided by density of water. You can write anything. Density of I would like to write density of liquid divided by density of water. So therefore density of liquid already we found out 713.5 kg per meter cube divided by density of water, that should be remembered 1000 kg per meter cube. 1000 kg per meter cube. So therefore if you simplify this one, you can get 0.71. Of course this is enough. 713 is the specific gravity of that liquid. What we can understand this specific gravity? So the weight of that weight density of that liquid less than the weight density of the water, so that you can understand that from this specific gravity. Suppose generally suppose you take oil, kerosene, petrol, all these things, their weight density are less than 1. So the weight density of the material which is less than 1, if you that liquid put into water, that will be floating on the water surface. That is the application, that is the practically we can understand that. Suppose the specific gravity is less than 1, that liquid if you put in water, that cannot that doesn't get dissolved in water, that will be floating on that water. Example, you take kerosene, oils, you take any oil, cooking oil or all these things, they are floating on the water because their specific gravity is less than 1, which means that weight density of that oil is less than the weight density of water. Suppose if you take any solid, the weight density is more than 1, which means that weight is more than the weight density of that material is more than the water. So that if you take any rock, that weight density is more than water, so that if you throw that stone into the water, that is going through the water, that is settled down, passing through the water. So because that weight density more than water, that's why that is going through the water, it will settle down at the bottom. So less than 1 materials, obviously they are floating on the water. Greater than the 1, generally they can pass through the, if you throw into the water, they can pass through that water, they can settle down at the bottom. So these are the things we can understand from this problem.